Michael, what's today's audio topic?
Today we're reviewing Topping's DX9 Discrete DAC.
So, it's a review of a DA converter. Master, you want to hear about the DX9 Discrete too, right?
Yes, I want to hear about it.
By the way, we've talked about Topping's DAC before, haven't we?
The D900, right? The DX9 Discrete has a lot in common with the D900, but for now, let's focus on the DX9 Discrete.
I see. What equipment did you use?
The music source was Qobuz, the network streamer was LinkPlay's WM Ultra, the amplifier was SM Cell's PA200, and the speakers were B&W's 705S3.
What is the price of the DX9 Discrete?
It's $1,299. It's a mid-range DAC.
What are the key features of the DX9 Discrete?
The DX9 Discrete is a product that integrates a DAC, headphone amplifier, and preamp into a single unit. Its most distinctive feature is that it doesn't use DAC chips from companies like ESS or AKM. Instead, it employs Topping's proprietary PSRM phase-switching reference modulator, 1-bit discrete DAC circuit.
Didn't we hear about PSRM before?
That was back when we talked about the D900. Let's review what PSRM is. PSRM is a proprietary 1-bit discrete DAC architecture developed to overcome the limitations of conventional DAC chips. Conventional DACs from companies like ESS and AKM pack all their circuitry into a small silicon chip. In contrast, PSRM builds the DAC circuit by arranging general-purpose ICs and resistors on the board. This type of configuration is called discrete.
Most discrete DACs use the R2R method, right? Isn't PSRM built with a similar structure?
The R2R method is multi-bit, but PSRM processes signals in 1 bit.
What's the difference between multi-bit and single-bit?
There are two types of DA conversion, the R2R method and the delta sigma method. The R2R method is multi-bit, while the delta sigma method is single-bit processing. Let me explain the characteristics of each. First, let's look at the multi-bit DAC, R2R method. Multi-bit processing is an intuitive conversion method, similar to building a staircase one step at a time. The principle involves outputting a voltage that corresponds directly to the number of bits in the input digital data. For example, with 16 bits, a 16-element resistor ladder, R2R ladder, is used to add voltages together based on the on-off state of each bit. For each bit of data, the voltage passes through a precision resistor corresponding to that bit's weight, and the summed voltage is output. The advantage is that the conversion process is very simple and relatively tolerant of timing accuracy, jitter. The disadvantage is that the precision of the resistors is critical. To reproduce the extremely small voltage differences found in 16-bit or 24-bit systems, ultra-precise resistors with an error margin of less than 0.001% are required, which causes costs to skyrocket. Next, let's look at the 1-bit DAC, delta sigma method. 1-bit processing is the mainstream method today, akin to adjusting brightness by rapidly flickering a light. The principle involves reducing the number of bits to the absolute minimum, 1 bit, and compensating for this by drastically increasing the sampling frequency, oversampling. Delta sigma modulation rapidly repeats the change, delta, and accumulation, sigma, of data, expressing sound volume through variations in the density of zeros and ones. Noise shaping is used to push the vast amount of noise generated by the 1-bit conversion into ultra-high frequencies that are inaudible to the human ear. When high-frequency noise is finally filtered out using a low-pass filter, a smooth analog waveform remains. The advantage is that it doesn't rely on the precision of resistors, allowing for high resolution at a low cost. Over 90% of modern DAC chips use this method. The disadvantage is that the digital processing is complex, and it's said to be prone to producing a digital harshness in the sound due to the calculations.
PSRM is the same as the delta sigma method if it's 1-bit processing, right?
That's where it differs slightly from the standard delta sigma method. PSRM uses 1-bit processing like the delta sigma method, but it doesn't use a DAC chip. It arranges a large number of discrete 1-bit elements in a parallel configuration and controls them in a matrix-like manner to generate the analog waveform. PSRM utilizes the smoothness and linearity of the 1-bit method, but by building the circuit with discrete components rather than inside an IC chip, it achieves this sense of energy derived from substantial hardware investment found in multi-bit systems.
That's right. The PSRM feels like it combines the best of both our 2R and delta sigma methods.
Exactly. To put it simply, the PSRM is a brilliant design that delivers the transparency of a 1-bit system through a luxurious, multi-bit class circuit. The DX9 Discrete features a 16-phase PSRM module for each left and right channel. Its proprietary 1-bit architecture, built with high-speed switching logic ICs and high-precision voltage reference circuits, achieves both extremely fast response and signal fidelity.
I see. The DX9 Discrete uses a unique DA conversion method to deliver high sound quality.
That's right. Next, let's talk about the DX9 Discrete as power supply. Since ultra-high-speed digital switching at the nanosecond level tends to cause noise, Topping developed a proprietary, resistor-based output power supply to maintain analog precision. As a result, despite its discrete configuration, it achieves an astonishing 131 dB dynamic range and 131 dB signal-to-noise ratio, ultra-low noise, and high specifications that rival those of IC-based units. The most distinctive features of the DX9 Discrete are its see-through top panel and dual Aurora UI. The top panel features a glass panel with a detailed circuit diagram, and the internal discrete circuitry is beautifully illuminated by ambient lighting. It's truly beautiful and elegant. Plus, it's fascinating to see which board corresponds to which circuit. The front panel features two 2.0-inch color LCD screens capable of displaying VU meters, FFT spectra, and playback information in real time.
It's rare to see a device with such a striking visual impact.
That's true. It's rare to see a chassis that reveals its internal structure, and the orange interior lighting is so lovely that just turning it on puts you in a good mood. The front panel features a power, multifunction button, volume control, and headphone jacks for 6.35mm, 3.5mm, and 4-pin XLR connectors.
It has a great selection of headphone jacks.
That's right. The DX9 Discrete has 3 headphone jacks, so it's clear they're putting a lot of effort into headphones as well as hi-fi systems. The rear panel has one set each of XLR and RCA pre-outs and line-outs, along with digital inputs including I2S, 2 coaxial, 2 optical, Bluetooth, USB-B, AES, trigger input-output, and a power switch.
The digital inputs are impressive too.
Since the DX9 Discrete is Topping's top-of-the-line model, it offers not only great headphone support, but also a comprehensive range of digital inputs. The included accessories are a remote control, power cable, USB cable, Bluetooth antenna, and headphone adapter. This remote control is compact and has a very high-quality feel. In terms of features, it includes a PEQ. There are 5 default presets and 5 user-configurable presets, for a total of 10 options to choose from.
What was PEQ again?
PEQ stands for parametric equalizer, which is a feature that allows you to adjust specific frequencies in the music with very high precision. It offers far more flexibility than the graphic equalizers found on typical audio equipment and is a serious sound tuning tool. But I think the sound actually sounds clearer when the PEQ is turned off.
How does the DX9 Discrete actually sound?
I tried both the XLR and RCA pre-outs as well as the line-out, and the line-out, which bypasses the volume circuit, sounded better. I couldn't tell the difference between the XLR and RCA line-outs. The sound from the DX9 Discrete is quite high resolution. It also has a certain luster to it. Since it uses Topping's proprietary circuitry, it doesn't sound like other manufacturers' DACs. I think it has a very appealing sound. Previously, Onyx's Zenith XDA20, which features 2 ES9039 Pro chips, had an incredibly crisp sound. The DX9 Discrete doesn't quite match that level of crispness. However, its slightly mellower sound is very easy on the ears.
Does Topping's D900 have a similar sound character? Since the D900 and DX9 Discrete are from the same manufacturer, do they sound the same?
That's definitely something to look into.
Everyone, it's almost closing time.
It's getting late. Next time, let's hear a comparison between the DX9 Discrete and the D900.
Got it. See you next week. If you enjoyed this video, please give it a thumbs up and subscribe to the channel.